correction to our assignment. So from our assignment, we have question 1. We have CH3, CH3, then we have H bonded to CH2, 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 CH3. Now, remember rule number 1? Rule number 1 says the longest continuous carbon chain. The longest continuous carbon chain. So we need to pick our longest continuous carbon chain. And let's see. From here we have 1, 2, 3, 4. We have 4 as our longest continuous carbon chain. But this is not correct because this carbon atom here can also as well, this one of these 2 carbon atoms can join together with this carbon chain. This one, this 4, they can join with this 4 to form a longer carbon chain. So let's see. If we count this way, 1, 2, 3, 4, and 5, we have a new long carbon chain. So which is here, the longest carbon chain here is 5, and 5 carbon represents pent. Now the IUPAC, the homologous series here is alkane, and it is alkane because of the presence of the single bond that we have between the carbon to carbon atoms. So the single bond there. Now in this case now, we are not counting this carbon atom. So this carbon atom, this compound here becomes a substituent. And what is the position for our substituent? 2. And the substituent here is methyl. So the name for this compound name will be 2-methyl pentane. 2-methyl pentane. And that is our option D. Yeah. Am I right? Yes. Option D. Option D. So let's go to question 2. Now, for question 2, we have this compound given to us CH3, C, Br, CH2, CH2, CH3. Again, the first thing is to identify your longest continuous carbon chain. And from what you can observe here, our longest continuous carbon chain is 1, 2, 3, and 4. 4 carbon atoms, which is butch. It's going to be butch. And here we are going to have 1, 2. We have 2 substituents, which are the bromines. 2 substituents, which are the bromines, and each one of them are on carbon 2. Lowest number possible to our substituents. Again, you must remember, always give the smallest number possible to your substituent. If I counted from here, 1, 2, 3. This number here will be 3. This here will be 3, and our bromine will be on carbon 3. So it is larger than if it is on carbon 2. So you give the number, lowest number possible to your substituent. So now, what is the name here for this compound? We already have our longest continuous carbon chain, which is 4, and we know because of the presence of the single bond in between the carbon to carbon atom, it is an alkane family, an alkane series, and that is the name here with butane. But the 2 substituents we have here are on carbon 2. So we are going to have 2, 2 dibromobutane. 2, 2 dibromobutane. And that is option that's option okay, so the option is not there since the option here is wrong. So this is 2, 2 dibromobutane. Since the option here is wrong because they also added methyl. So, but this is the real name, the real way of naming it. So this is 2, 2 dibromobutane. Now let's go to number 3. Question 3. Now for question 3, we have this compound CH3, CH2, we have CH3, CH2, then CH2, and CH3. Again, Pick your longest continuous carbon chain. Your longest continuous carbon chain. And what's our longest continuous carbon chain? We have 1, 2, 3, 4, 5, and 6. So our longest continuous carbon chain here is 6. That is the longest continuous carbon chain. So we have 6 here. Now this counting here is from left to right. We have another way we can number from right to left as well. So here now, since I know it is 6 and we have single bond in between the carbon to carbon atoms, then I know it is an alkane series. It is still an alkane series. And here we are going to have that the name will be, before I give the name, I need to identify my substituent. This is a substituent, and this as well is a substituent. And the two substituents are on carbon 3. They are on carbon 3. So this will be 3, 3 dimethyl hexane. 3, 3 dimethyl hexane, which is option, okay, here they are saying it should be isoheptane. Isoheptane, they want it to be an heptane compound, which, well, but this is the real name of naming it. So we have 3, 3 dimethyl hexane. Now let's go to question 4. Question 4. Question 4. So for question 4, we have CH3, CH2, and CH, and I have CH2, Cl, and I have another CH3 here. Now this compound here is very complex and it is quite different from this. It's easy, though, very easy. First, again, longest continuous carbon chain. The longest continuous carbon chain. But here, our longest continuous carbon chain here will be different. Why? Because of the presence of this chlorine attached to this carbon atom here. So instead of us to count it 1, 2, 3, 4, we won't be counting it like this. It will be like this: 1, 2, 3, and 4, because of this chlorine. So it will be 1, 2, 3, and 4, which makes this compound here a substituent. And this chlorine is also what? A substituent on its own. So this one will be carbon 1. Remember, give the lowest number possible to your substituent. Carbon 1, carbon 2, carbon 3, carbon 4. And here we are going to have 1 inorganic first before the organic. Inorganic before the organic. 1 chloro, then we are going to have 2 methyl butane. 1 chloro, 2 methyl butane. And this is the name of this organic compound here. The name of this organic compound. So 1 chloro, 2 methyl butane. Now let's go to question 5. Now for question 5, we have CH3, CH3. We have CH3 here, and we have CH2, and I have CH, and I have CH3 here, CH3, and I have CH2, and I have CH3 as well in this place. So now this compound here, again, first, your longest continuous carbon chain. Always remember that, your longest continuous carbon chain. So for this now, we're going to have that our longest continuous carbon chain is going to be 1. We have 1, 2, 3, 4, 5, 6. Now you might be wondering, why didn't I add this there? It's because I know these ones will not make it the longest, will not give it a longer shape. Like now, 1, 2, 3, very short. The same thing here, 1, 2, 3, short. 1, 2, 3, 4, 5. Still short. 1, 2, 3, 4, 5. Not up to this number that we have 6. 1, 2, 3, 4, 5, 6. Although you can also start to counting here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It will still be 6. So here we have 6 carbon atoms, which makes it X. X, and that will be hexane. Hexane here because an alkane series. So hexane, and we have substituents attached to it. This is a substituent, this is a substituent, and this another substituent. So this will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So 6 carbon X. So this is on these 2 substituents are on carbon 2. So I write 2, 2. Then I have another substituent again. So that will become 4. Try, because there are 3 of the same type. 3 of the same type. So try methyl hexane. Try methyl hexane. So now number 6. Number 6. Now for question 6, I have CH2, CH3, then bonded to CH, CH2, CH3, and then I have CH here. Okay, CH. Then I have here, there is an error here, an obvious error here, because everything here is supposed to be an alkane compound. So this is CH2, CH2, and CH3. So, like I said, there is an obvious error in this place here. There is an obvious error in this particular one here. And what's the obvious error? The number of bond here is not complete. The number of bond of this carbon atom is not complete. Like now, if I should write it out, carbon is supposed to have 4 bonds. So here we have just 1 H here. So there's supposed to be another H up here to make it 1, 2, 3, 4 bonds. To make it 4 bonds all complete. So this one here will be written as CH2. CH2. Yeah. So now name longest continuous carbon chain. I still am on that longest continuous carbon chain. So let's pick out our longest continuous carbon chain. Now 1, 2, 3, 4, 5. We still have other carbon atoms here. 1, 2, 3, 4, 5, 6, 7. But there is still another carbon here, so this makes it 8. Right? Now let's see. What if we start the counting from here? 1, 2, 3, 4, 5, 6, 7, 8. So which means our longest continuous carbon chain is still 8. Now what do I do with this one here? Now I can collapse this and make it a substituent. Now how do I collapse it? What I will do is just clean this up and then write C2H5 here in this case. C2H5. I add up the CH2 and the CH3 together. So our longest continuous carbon chain is 8, and that makes it oct. Oct. Now the number of carbon atoms 8, and the bond between the carbon atom is 1, and that makes it an alkane compound. So here now, what are my substituents? So this is my substituent, and I'm making this as well my substituent. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, and carbon 8. So here now, I am going to name it. Now this is ethyl, quite different from this, that is methyl. Ethyl is quite different from methyl. Ethyl has 2 carbon atoms, while methyl has 1 carbon atoms, but both have a loss of hydrogen from their ethane brothers. So here now, I'll write the ethyl first before, this will change, because if we write the name now, this one will be 3 ethyl, 7 methyl. But if I write 1, 2, and I make this 3, 4, 5, 6, 7, and 8. It is not variable 3 and 7. This one here is going to be 2 and 6. So numbering it right to left gives it a lower substituent than when I number left to right. So this is going to be 6 ethyl, 2 methyl, and octane. So 6 ethyl, 2 methyl, octane. So that is the compound here in this case. So now let's go to question number 7. I hope you are following through. If you have any question after watching this video, I'm going to do the first 10 today. So after watching this video, you can just drop a question on the 10. Anything you don't understand, I will attend to it in the group. So now let's see question 7. Now question 7 has a skeletal structure for the compound. So we have to name this compound. So by giving this skeletal structure, so we are given this skeletal structure and we are asked to name the compound. So again, longest continuous carbon chain, we have carbon 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The longest continuous carbon chain here is 6. Now, if this is our substituent here, because I am not naming this carbon atom together with it, so it becomes the substituent. That is the substituent. You must always identify your substituent. Now, if I follow through with my left to right, the locant, the position of our substituent group will be on carbon 4. But if I follow with right to left, the locant of our substituent group will be on carbon 3. Now, which one has the lower one? It is the one right to left, and that is what we are going to follow. So this is going to be 3 methyl hexane. 3 methyl hexane, and sometimes we call it isoheptane because it has 7 carbon atoms, so it can be an isomer of heptane. Now let's go to question 8. Question 8. Now in question 8, we are given 2 compounds and we are asked to look for their IUPAC names. We are given CH3, CH double bond, CH2, and we are giving HO, CH2, and CH2OH. So we are asked to get this compound. Now let's start from the first two. So we have CH3. So I'm going to write it out this way. I'm going to draw out the structure. CH3, then CH double bond CH2. Now, if you check, the double bond makes the number of carbon atoms around this compound complete, and also this one complete. 1, 2, 3, 4, 4 bonds. 1, 2, 3, 4, 4 bonds, all complete. So, what's going to be our name? Our IUPAC name. Longest continuous carbon chain is 1, 2, 3. We have 3, and that is prop. So here now, this is going to be prop 1 in. Why is it in? It is in because of this double bond, and that's our functional group. Our functional group, it is in because of this what? Double bond. And why is it prop 1 in? Because it is on carbon, it is on bond 1. This one here is bond 1, and this one here is bond 2. So it is on bond 1, that's why it is prop 1 in. So prop 1 in. Yeah, or sometimes some people say 1 propene, but I'll prefer you use this name rather than this one. This one is archaic. So 1 propene is quite old. So we use to 1E, which is the accepted bond by IUPAC. Now the second compound, when written out, let's start with the carbon atom. We have two carbon atoms here. So I'll put my OH here. Then I have H2. H2. So what is the name of this compound here? I have two carbon atoms. I have two carbon atoms, which makes it Earth. Earth. Two carbon atoms, Earth. And here, the functional group here is my OH, which represents alkanols. Alkanols. So which means the name of the compound will have the all compound there. So here now, this is my carbon 1 and carbon 2. So this will be ethane 1,2-diol. Ethane 1,2-diol. This is the name of this compound. Diol because of presence of two alkanols. So it will be ethane 1,2-diol. Now let's look at question number 9 and 10 as we bring everything to a close. Question number 9 and 10. Question number 9 and 10. So for question number 9, I have that CH3, and I have CH2. I have my CH2, C, and I have CH3 here. Then I have double bond C, and I have CH3, CH3. Now, again, this compound is quite similar to this one here, in the sense that from it you can identify the functional group. The functional group is this, and that's our alkene. Our alkene. So the name of this compound will have the in at the end of the name. So have in at the end of the name. So since I already have my functional group identified, then let's pick my longest continuous carbon chain. Now what's my longest continuous carbon chain? I have 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So this is X. And the name of this compound will be hexane. Hexane. But not just hexane, because I must identify the locus, the position of this double bond. I must bring out the locus for this double bond. So here, this compound, I will number. Now, I will number from the side closest to my functional group. So the numbering has to start from the side closest to my functional group. This one will be 1, 2, 3, 4, 5, and 6. So these are my substituents. These are my substituents. And this is bond 1, and my double bond is on bond 2. So I'm going to stop it. So now I have a name. Longest continuous carbon chain is 6. X. Homologous series is alkene because of the presence of the functional group of double bond functional group, and that makes the name hexane. And the locus, the position for the double bond is on carbon 2. That makes it X2E. And I have two substituents which are similar. The methyl, one is on carbon 2 and the other is on carbon 3. So I'll write 2,3 dimethyl X2E. 2,3 dimethyl X2E. So this is the name for this compound here in question number 9. And finally, question number 10. Now, for question number 10, we have C2H5 here. Then I have C double bond. Then I have CH, and I have my CH3 here. And I have my CH3 as well here. So, what is the name for this compound? Again, you pick your longest continuous carbon chain. Now, my longest continuous carbon chain here, we have two carbon atoms here, which if I expand this now, so it will be CH3, CH2 from this C2H5, then CH3 double bond C. I can put my H here, Let me put my H as well down here. And then this CH3 I bring to the front here, CH3. Now, with me expanding it, I have my longest continuous carbon chain. And what is my longest continuous carbon chain here? Number 1, 2, 3, 4, and 5. I have 5 carbon atoms. That makes it pent. And the functional group here is our double bond. And that's the alkene series. And that makes the name pentene. And we are numbering from the side closest to my functional group. I have 1, 2, 3, 4, and 5. So this is on bond 1, and this as well is on bond 2. So this now gives the name my substituent. This becomes my substituent. So what is the name of this compound? I have 3 methyl, and this is pent 2-ene. 3 methyl pent 2-ene. So that is all on the 10 assignment. I know I gave 20 questions, but I want to break the video down so that we watch the first 10, and then if you have any questions, you can drop it into the group. For me, I will attend to if you do not understand anything. So let's call it a day here. Thank you very much. See you for the part 2 of this.